In this video, I'm going to show you how to find and use the formula for the nth term of an arithmetic sequence. So here's our first problem. We want to find the formula for the nth term of the following arithmetic sequence: 3, 7, 11, 15, and so on. And then once we have that formula, we'll want to use that formula to find the 31st term of the sequence. But for now, our focus is on finding the formula for the nth term. So to make things very clear, why don't we start by filling in a table of n versus an. When n is 1, that just means the first term of the sequence, and the first term of the sequence, a1, is 3. Then when n is 2, that's the second term of the sequence, so 7 over here. And then when n is 3, that's the third term, so go to third term here, 1, 2, 3, 11. a3 is 11, and so on and so forth, and our goal is to find an as a function of n. Now, one thing to notice here is that each term is just 4 more than the previous. We start with 3 and then we add 4 to get to 7, and then again we add 4 to get to 11. So we'll just be continuing that pattern of adding 4 on and on and on as we get more terms of the sequence. Okay, so let's write the terms of a sequence again, but now let's use the fact that we're adding 4 each time to make the pattern very, very clear for the formula. So first of all, we have a1 equals 3. That's just what we start with. Now we know that a2 is equal to 7, but let's write it in terms of our starting case, a1 equals 3, and then adding 4. So instead of writing 7, let's write 3 and then plus 4. Now for a3, let's continue that pattern. a3, we start with our first case, 3, and then we add 4. That brings us to a2. So this here is a2, and then we have to add another 4 to get to a3. And let's just write down one more row. So a4 would then be 3. Can you see the pattern here? Then we just have plus 4, plus 4, plus 4. So let's see if we can write down a general pattern. an equals, well, of course we're starting with 3, and then we've got a whole bunch of 4s after it. Plus 4, plus so on, even more 4s, and plus 4. So how many 4s do we have here exactly? Well, let's look back. When it was a4, we had 3 4s. When it was a3, we had 2 4s. When it was a2, we had a single 4. So basically, we just need to subtract 1 from this subscript of the a, and that tells us how many 4s we have. So for an, we should just have n minus 1 copies of 4. n minus 1 4s being added together. So there we go. We can write the general formula then. an equals 3, and then plus n minus 1 copies of 4, and we can condense that into just saying n minus 1 times 4. Okay, so that is our general formula for the nth term of this sequence, and now we'll go ahead and use this to find the 31st term of the sequence. So why don't we do that up here? We'll find the 31st term of the sequence using this formula. So we want to find a31, and to do that we just need to plug in 31 for n here. So 3 plus n minus 1, n is just 31, so 31 minus 1 times 4, and just go ahead and evaluate this. So a31 is equal to 3 plus 30 times 4, so that simplified, a31 is equal to 3 plus 30 times 4 is just 120, so a31 is equal to 123. And there we go. There we have it. Great, so now let's look back at our work and see if we can generalize this formula to any arithmetic sequence so that we don't have to go through all this work every time to come up with our formula for the nth term. So let's look at the parts of this formula here. So an equals 3. Where did 3 come from? Well, 3 was just a1. 3 is the first term of the sequence. So 3 is just a1, the first term. And then how about 4? Where did that come from? Well, 4 was the amount that we're adding every single time, and that's called the common difference. D, the common difference. So using this notation, we can come up with a kind of formula that will work for any kind of arithmetic sequence, and we'll write it over here. So an is equal to the first term, a1, plus n minus 1 times the common difference, d. And there we go. There is our general formula for any arithmetic sequence. Great, so now that we know how to write the nth term of an arithmetic sequence, let's go ahead and do some more examples. First of all, we want to find the formula for the nth term of an arithmetic sequence whose first term is 5 and whose common difference is 7. Why don't we start with the template that we created on the previous slide. We just have the equation an equals a1, the first term, plus n minus 1 times d, where d is the common difference. So this is just a matter of taking information from the problem and subbing it into our formula here. So the first term is 5, so we can sub in 5 for a1 here. So an equals 5 plus, and then the rest of it, n is just our variable, so we keep that in the formula. But d, the common difference, that's just 7. Common difference is 7 right over here. And so we sub that in for d here. So plus n minus 1 times 7. And we can even simplify this a little bit by distributing the 7 over the n minus 1. So let's go ahead and do that. So we get an equals 5 plus, distribute the 7 over the n minus 1, you get 7 times n is 7n, and then 7 times minus 1 is minus 7, and then go ahead and simplify that. An equals, well, we've got a 5 minus 7, and 5 minus 7 is negative 2, and then plus our 7n. So there we go. There is our formula for the nth term. Okay, next question. We want to find the 70th term of the following sequence. 1, a half, 0, negative half, and so on. Okay, so the way we'll do this is we'll just find the general formula, and then we'll stick in n equals 70 into the general formula once we've found it. So let's start off with our template here. An equals a1 plus n minus 1 times the common difference. And then we'll look at our sequence here and fill in our formula as appropriate. So our first term is 1 here. So that's what we'll fill in for a1. So an equals 1 plus, and now we have to look for the common difference. Common difference is the amount that we're adding every time. And this time actually, the sequence is going down. It's getting lower and lower. We're actually subtracting some amount. And you can think about subtracting as adding a negative amount. So what do we subtract from 1 to get to 1/2? Well, we just subtract a half. So it's like we're adding negative a half. And then we do that again. Subtract a half to get to 0. So add negative a half, and so on. Continue that pattern, adding negative a half over and over. So our common difference is then negative a half. So n minus 1 times negative a half. Now we're ready to find the 70th term here, and we can just stick in n equals 70 into this formula. So let's go ahead and do that. A70 is equal to 1 plus 70 minus 1 times negative a half. And we'll just go ahead and compute that. So that's equal to 1 plus 70 minus 1 is 69. So 69 times negative a half. So that's 1 plus 69 times negative a half is, well, why don't we just write that as negative 69 over 2. And then we just have to do a bit of fraction arithmetic. So 1, let's convert that to have a common denominator of 2. 1 is just 2 over 2. So we have 2 over 2 minus 69 over 2. And 2 minus 69 is negative 67. So we just have negative 67 over 2. So that's our value for A70. A70 is just negative 67 over 2. Great, so now we know how to find and use the formula for the nth term of an arithmetic sequence. And in the future, we'll continue to learn other ways in which we can use formulas for arithmetic sequences.